It's very important that you have a clear understanding of the difference between heat and temperature, because we're going to be using both and they're not the same thing. So heat is the amount of energy that a substance contains. And temperature is the average kinetic energy of the particles. So this one here, has a very high temperature. So it is maybe, let's just say it's like 100, 200 degrees Celsius. I don't actually know. It might actually be 500 degrees Celsius. Let's go 500. 500 degrees Celsius, a bit like a Bunsen burner. This one here is just maybe a cold bath. Maybe it's only like 10 degrees Celsius. So the kinetic energy of the particles is nowhere near as high as these ones. This is like a plasma here, which is a state that was not covered. So solid, liquid, gas, plasma, by the way. And so what the difference is, even though this has the higher temperature and this one has the lower temperature because of the kinetic energy of the molecules, the amount of heat it actually contains is different because this has a very large mass. And so even though there's a difference in the kinetic energy, there's just so many particles here, it may actually contain more heat than the small match, because the match has a very, very, very tiny mass. Okay, so just remember, so heat is the amount of energy something contains, which is related to how much mass there is. Okay, whereas kinetic energy is just how fast the molecules are moving. Okay, so once again, the heat dissipates out very quickly, and that's because of entropy. So we haven't got anywhere, and we talked about entropy already, and converting between Celsius and Kelvins in your data booklet. So technically, 0 Kelvin is no temperature, and so put that on the other side, that's minus 273.15 degrees Celsius. Okay, now the last thing is just a diagrammatic example of that. This is a Maxwell-Boltzmann curve, and so you can see that that's the average kinetic energy. So that will be the temperature right here, and that's the temperature here. But the average kinetic energy. So you've got particles that have more or less kinetic energy, but on average it's around this point here and this point here, relatively speaking. And just relating this back to heat, if this is a really tiny sample and this is a really large sample, it may be that this contains more heat, even though it's colder than this one here. And that's in joules. And that one's in Kelvin.